So in Pythagoras triplets, can you tell me what is the general formula of all the three Pythagoras triplets?
Ma'am, 2m m square plus 1 m square minus 1.
Yes, we have 2m, m square minus 1 and m square plus 1. So amongst these, which is the biggest?
Ma'am, I'm getting my note.
Which one is the biggest, Mustafa? Mustafa, do you hear me?
Yes, ma'am, I'm getting my notebook.
Okay, yeah, fine. Okay, so Mustafa, please study that there is a general form for writing all the three Pythagoras triplets, which is 2m, m square minus 1 and m square plus 1, right? And amongst these, m square plus 1 is the greatest if you remember. Isn't it? Then we practiced various questions. Now I also gave you a homework question. Did you complete your homework?
No, ma'am.
So in the homework question, Mustafa, I gave that one of the member is given to you and then you have to identify the other members. Right. So now we'll come to the next set of questions. Do you have any doubt till here?
No.
Everything clear?
Yes, ma'am.
Okay. So the next topic, let me just see. Finding the square numbers. Okay. So how do you find the square numbers? Now what we have here is let's suppose you have a number. Let's say 39. Okay. And now I say find the square of 39 without multiplying. That means I'm asking you what is 39 square, but you don't have to do it like 39 into 39. You don't have to follow this method. So without following this method, you find the square. So what you're going to do, you can use identities. Now, what are the identities? Like, can I break down 39 and can I write it as 40 minus 1? Can 39 be written like this? And then I put a whole square over it. Because 39 is equal to 40 minus 1 and then I put a whole square. Now, which identity do you think this is, Mustafa?
Ma'am, I don't know the exact.
A minus B whole square. See, this becomes A minus B whole square, which is opened as A square plus B square minus 2AB. Okay, this is how you open up this identity. So here 40 is A and 1 is B. So it becomes A minus B whole square, that becomes 40 square plus 1 square minus 2 into 40 into 1. This is how you open it. Now, what is the square of 40? 40 into 40 becomes 1600 plus 1 into 1 becomes 1 minus 2 into 1 becomes 2 and into 40 becomes 80. Okay, now you will just solve it. 1600. Okay, plus 1
16.
and minus 81. What does it become? Minus 79. And now you can subtract 1600 minus 79. Right? What does it become? 1, 2, 5, 1. So what is your answer? 1521 is the square of 39. Alright, see, I did not multiply and I also got my answer. So this is one way. When you have 42 square, let's suppose you have to now find out 42 square without actual multiplication. Now how can I break down 42?
40 plus 2.
Exactly. I can break it down as 40 plus 2 whole square. See, one more thing. This question can also be solved by taking these two pairs, 30 plus 9 whole square. Then also you will get the same answer. Okay. But I always
Yes, ma'am.
suggest that go for simpler numbers. Like I'm getting 1 here. So 1 is much simpler than 9. So it will be easier calculations. So similarly, this can be broken down as 15 minus 8 also. But since 40 plus 2 both are very small numbers, so these it will be easy calculations. So you can do it like this. So here your identity becomes a plus b whole square is equal to a square plus b square plus 2ab. Okay, your identity becomes like this. So 40 plus 2 whole square becomes 40 square plus 2 square plus 2 into 40 into 2. All right. So this becomes 1600 plus 4 plus 160. So you'll get 1600 plus 164. You'll get 4, 6, 7, 1. So this will be your answer. So such type of questions can you now do by using these identities? You just have to clearly remember these two identities. Okay, Mustafa?
Yes, ma'am.
And similarly this one. So what do you have next? Next question says, okay, now there is one more one. Finding the square of the numbers that contain 5 in the units place. Now there is a short trick to that. What is the trick? Whenever you will have 5 at the unit place, let's suppose you have a number 15 and I say find the square of 15. So you don't have to use all this method also. You don't even have to multiply. There is a direct trick to this. What is the square of 5?
25.
25. And what number is over here, Mustafa?
1.
1. Now which number is 1 more than 1? Next number after 1. What is the
2.
successor?
2.
2 is the successor. So you will multiply this number with its successor. So 1 into 2 gives you 2. So you will write 2 over here. So the answer becomes 225. Now let's suppose I have to find the square of 25. So what will I do? So 25 square. Again, what is the square of 5? 25. And now what number is over here? 2. What is the successor of 2?
3.
So you'll multiply 2 into 3. What do you get? 6. So the answer is
65.
625. So similarly, for the numbers which has 5 as its units place, it becomes very easy to solve their squares. Okay. Let's suppose you have 105 squared. So this also, what you will do? What is the square of 5? 25. The number here is 10. So 10 into 11 is 110. So write 110 before 25. All right.
Yes, ma'am.
So do you understand both these methods?
Yes, ma'am.
Now we completed Pythagoras script also. You can do one or two questions of this type, then we move ahead. Find the square of following. The first number is 32, second number is 35, and third number is 93. Okay, you have to find the square. So can you tell me how will you find the square of 32?
Ma'am, a square.
First, you'll
I
break
mean,
it up.
yeah. 30 plus 2 is equal to 32. So,
So 32 square becomes 30 plus 2 whole square.
yeah, uh, and then it breaks down to 30 square plus 2 square,
Okay, plus,
10 plus 2 multiplied by a and multiplied by b.
yes. So 2 into A into B. So what is now 30 square?
900.
900 plus 4 plus 120.
6 over here 120.
Okay, then you add all of these. You get 4, 2, 10. 1024 is your answer. Now for the number with a 5 at its unit place, what will be the answer? 35 square is equals to?
Uh, yeah, 5 square is equal to 25,
Okay,
and then 3 times 4 is 12.
12. So you get 1225. Next is 93.
90 plus 3.
Can I break down 93 as 100 minus 7 also?
Yes, ma'am.
So let's do it that way, okay? So you get 100 minus 7 square. Next,
100 square minus 7 square.
yes, plus 7 square
Oh, yeah, plus 2 square.
minus
Minus 2 into 100 into 7.
2 into 100 into 7. Okay, so 100 square is 10000
10
plus 49 minus
49.
1400. Okay, so what you'll do? Let's first solve this part. 10000. So plus 49 minus 1400. What is it equal to? You subtract, or wait, let's do it that way. Just add it. Okay, add it directly and then subtract 1400. So you get 49 and 100 minus 14 will be 86. So 8649 will be your answer. Okay. Rida, are you there in the class? Put on your camera and mic.
Yes, ma'am.
Okay. Rida, you are again joining the class late. What is the reason of joining so late?
Ma'am, I was facing some network issues and I'm really sick. That's why.
Okay, Rida, have you watched the previous recordings of the classes?
I know I will watch it today.
Okay, no problem. See, Rida, now we have started with a new topic, which is squares and square roots. Now I have completed half of the lesson. Squares I have completed. From today onwards, I have to start with a new topic, which is square roots. Okay, so please pay attention in the class. Whatever you understand, try to focus. Else, you need to watch the previous recordings of the class to just catch up with everything. Okay. So we have the topic square roots now. Now, what are square roots? Basically, when I have a number, let's suppose I have 25. Now, I know that 25 is a perfect square. So, 25 is a square of what number? Okay, that is known as square root. One minute, Sharon. Okay, children. So now if I have 25, so let's try to find out that 25 is the square root of which number? 25 is the square of which number? So can you tell me 25 is the square of which number?
5.
5. So 25 is equals to 5 square. So that means 25 is the square and 5 is the square root. Okay. So can I write down 25 under root 25 is equals to 5? Okay, this is one way of writing. Then let's suppose I have 36. So I know 6 square is equals to 36. That means under root of 36 will be equal to 6. Okay, that means what is the square root of 36? It is 6. And what is the square of 6? It is 36. So this is how you will proceed with such type of questions. Now, what do we have next? Finding square roots. So how do you find the square roots? Like, let's suppose you have 11 square is 121. Can you tell me what is the square root of 121?
11.
11. Then if it is given 14 square is 196. So what is the under root of 196?
14.
14. Okay, so these are very simple questions, just concept building. Now we have finding square roots through repeated subtraction. So if I say that what is the square root of 81?
Oh, ma'am, I think we did this.
Repeated square roots part.
Yes, ma'am, we did this. Repeated subtraction, we did.
See, Mustafa, we have done repeated subtraction for squares. Okay, for finding the square of the number. Like we did. See, that time, what was the question? Like, what is the, like, the question was 36 is the square of which number? Do you remember this type of questions we did? So what we
Yes,
used to do, we used to subtract an odd number, then then next odd number, then next odd number, and we used to keep on repeating. And whatever we used to count the numbers. Okay, so this is the same method only. It's just they'll write the question as like what is the square root of 121. The method remains same only. I just want to practice this question so that you don't get confused by seeing another type of question. Like see, the language of the question is different, but the method remains same. What they're asking you, the basic of the question remains the same only. What are they asking you? That 121 is the square of which number? Or what is the square root of 121? Right, so what we will do here, Rida, are you there?
Yes, ma'am.
Rida, please do not put off your camera.
Okay.
So now if you have to calculate 121, so what will you do in this question? Pay attention. We are going to continuously subtract odd numbers. What is the first odd number? 1. So you will subtract 121 minus 1. You get 120. Then you do 120 minus 3. You get 117. Then 117 minus 5. You get 112. 112 minus 7. Okay, and so on. So you're going to just keep on repeatedly subtract the odd numbers until you get a 0, and then count that how many numbers did you subtract. Here I directly know 121 is the square of what number? I told you to learn the squares. 121 is square of which number?
11.
11. Very good. So I directly know the answer, but I still have to follow the method. See, now how does this help me that 11 is my answer? Like, since we've already learned that what are the like squares of 1 to 20. So this will help me in exams. Like I quickly can write down all the numbers. Like I know 11 numbers will be there. So in exams, it becomes very easy for me. Okay, so always learn all the squares from 1 to 20. So now we come to the next question. Finding square roots through prime factorization. Now we have one more method of finding square roots. Let's suppose there's 121 only. Now I say Do not use that repeated subtraction method. Instead, use the prime factorization method. So what is the prime factorization method now? You are going to do the prime factorization of 121. So what do I get? 121. Okay, wait, let's take another number first because here I directly have to take 11. Let's take 36. Okay, so I know first I will get 2 into 18 is 36. 2 into 9 is 18. 3 into 3 is 9 and 3 into 1 is 3. So that means, can I write 36 as 2 into 2 into 3 into 3? Right. Now, out of the prime factors, I have all the prime factors as pairs. See, 2 is present as a pair. Then 3 is also present as a pair. Right. So now what will I do? From the pair, I'll just take one number each. Like from 2 into 2, I will just take 2. Then here I will just take 3 and I will multiply these numbers and I get 6 as my answer. So your answer is 6. So whenever you have to do prime factorization method, what you will do, you will first prime the prime factors of the given number. Then you will make pairs of the prime factors and then you will multiply those pairs. Okay. So I'll give you a few questions. Let's suppose 324. Can you do prime factorization of 324?
Yes,
Tell me,
ma'am.
children. Rida, what about you? Rida, find the prime factors. Both of you quickly find the prime factors and then we'll see to it.
Mom, is it 13?
Rida, you have to find the prime factors first and then you have to come to the answer.
Done, ma'am.
Okay, completed. What about Rida? What about Rida?
Yes, mom.
Okay. So what we have here is 324. Yes. So who will tell me the answer, Rida? You tell me. How will you do the prime factorization of 324?
Mom, 3 into 3, 6.
First, what you will take?
3.
Why 3, Rida? First you will take 2 because this is even number. So you take 2 first.
Okay. 2 into 2, 6. I'm say 4. 2 into 2, 4.
So Rida, how do we do prime factorization? Rida, am I audible to you?
Yes, mom.
Okay, one more thing, Rida, please align your camera in a way that I can see your face. Align it in a proper way. Yeah, Mustafa, you as well. Okay. So in 324, how will we do the prime factorization? Tell me, Rida. First, you will divide with 2. So when you divide with 2, what is your answer?
1, 4.
When you divide 324 with 2, what is your answer?
Oh, I can hear you.
Am I audible?
Yes, now you are.
Children, what is wrong? Mustafa, do you hear me?
Yes, ma'am.
Yes, Rida, please tell me when you divide 324 with 2, what do you get?
Mom, into what? 20?
Rida, can you see my screen?
I do, ma'am, but the background noises are coming when you're speaking.
Okay, children, please wait for 2 minutes then.
Okay.
Yes. Now let's divide. Rita, tell me when you divide 324 by 2, what do you get?
324 by 2.
I'm waiting for your answer.
Ma'am, I don't know.
You don't know how to divide, Rita. That's not possible. You are not even dividing. You're just
I know
thinking
how to
of the
divide,
answer.
but I know how to divide, but I can't understand your question.
I'm just asking you a very simple question. When you divide 324 with 2, what do you get?
Oh, okay. I can't hear your voice, and that's why I couldn't answer it.
Look here. What we will do, we first divide 324 with 2. You get
122,
100.
22.
No, that's wrong. You first divide by 2. So 2 into 1 is 2. So 1 will be carried over here because it is 3. 2 into 6 is 12. 2 into 2 is 4. Then again, it is even number. You'll again divide with 2. 81. Now 81 can't be divided by 2, but it can be divided by 3. So you take 3, 2 times and 7 times. Again 3, 9 times. 3, 3 times and 3, 1 time. So the prime factors of 324 are 2 into 2 into 3 into 3 into 3 into 3. Okay, now you make pairs. So one pair, second pair, third pair. So you get 2 into 3 into 3. Okay, so what do you get? 2 into 3 into 3, what does it give you?
It's 12.
Into 3 is 6 and 6 into 3 gives you 18.
18.
Okay, 18 is your answer. Now we come to the next question. Any doubt in this one?
No, ma'am.
Rida, what about you? Any doubt in this question?
No, ma'am.
Okay, now again we have, let's suppose I ask you a question. Is 90 a perfect square? See, now this type of questions we have solved by using two methods. Till now, we used to look at the last digit. If you look at the last digit of 90, what is it?
0.
0.
So according to the last digit, it can be a perfect square, isn't it? But we also used to check for another method. What was the another method? We had repeated subtraction.
Yes, ma'am.
Yes, we had repeated subtraction. If our answer was yes for, see, if for example, the question was 97, I directly know it is not a perfect square. So you'll just directly write no. But when you have a perfect square number, so you have to go through various checkpoints. First, you will look at the units place. It is 9090, so 0 can be a perfect square. We don't know directly yet, so you'll come to repeated subtraction method. In the repeated subtraction method, we used to keep on subtracting until we get a 0 at last. And if you don't get a 0, you get a negative number, then it is not a perfect square. Now we come to a third type of method in this exercise, which is the method of prime factorization. So with prime factorization also, you can check it if it is a perfect square or not. Prime factorize 90. What is my answer? 2 into 3 into 3 into 5. Right? So can I make pairs of the factors now? I can make only one pair. Now 2 and 5 can't be paired up. Right? They are left alone. So whenever I will have the prime factors in a manner that I cannot make pairs out of them. So that gives me the idea that my given number is not a perfect square. Okay, like 90 is not a perfect square.
Ma'am, I have a question.
Yes.
Ma'am, so to make this a perfect square, we can multiply 5 and 2, right? So we
Yes,
got
very good. So for example, they might ask you, with what least number you must multiply to make it a perfect square? So your answer would be 10. Why? Because when you're multiplying with 2 and 5, that gives you 10 as your answer. So when you multiply 90 with 10, that's the least number with which you can multiply. Okay. So next question we have is, let's suppose the question is, first they are asking you, is 2352 a perfect square? So first find the answer to this much part of the question. Do the prime factorization of 2352 and then tell me.
Done, ma'am.
Kirita, are you able to do?
On time.
Okay, let's wait 1 or 2 minutes for Rida also.
Bob, can you explain this again if it's okay?
Okay, Rida. So what we will do, please look here on the board. So you have 2, 3, 5, 2. So Rida, how do we do prime factorization? You take the smallest number. The smallest number is 2. Okay. Now, can this number be multiplied with 2, divided by 2? So to check, you need to check if the number even or odd. If it is even, then it is divided by 2. Is it even or odd?
It's even.
Even. When you have
Yeah.
the last digit as 2 or multiple of 2, then it is even number. So you have 2, so this is even number. So now you will divide by 2. So 2. 2 into 1 time is 2. 2 into 1 time is 2. 1 carried over here. 2 into 7 times is 14. 1 carried over here. And 2 into 6 times is 12. Is this step clear? Please, Rida,
Yes.
respond. Is this step clear? Next you have is 1176. Now check for this number. Is it even or odd?
Ma'am, it's odd.
6 you get at last. Is it odd number?
No, it's an even number.
What are even and odd numbers, Rida?
Ma'am, it's the numbers which
Even numbers are the ones that are divisible by 2. Okay, the last number should come in the
Yeah.
table. 6 comes in the table of 2, yes.
yes,
So the entire number is even. Divided by 2. So 2 into 5 times is 10. 1 carry. 2 into 8 times is 16. 1 carry. 2 into 8 times is 16. 588. Is it even or odd?
Ma'am, it's even.
So can I divide it by 2? Yes. Right. So over here, 2 into 2 times is 4. 1 carry. 2 into 9 times is 18. And 2 into 4 times is 8. Again, 294 is also even. So divided by 2. 2 into 1 times, 2 into 4 times, and 2 into 7 times. Is 147 even or odd?
Ma'am, it's even.
Is 7 divisible by 2 without the 7 comes in the table of 2?
No, it's
Please
odd.
think and speak your answer. Okay, these things are not tough. You just need to go slow. Okay, it's okay. Go slow. Just think properly and then answer. So it's odd number. Now 147. Now you cannot divide it by 2 because it's an odd number. So what you will do, just check. Can it be divided by 3? So what is the divisibility test for 3?
Oh, yes,
Rida,
ma'am.
please don't focus on writing right now. Okay, don't copy right now. Please first learn the concept. What is the divisibility test of 3? You add all the digits and check for your answer. You add 1 plus 4 plus 7. So 1 plus 4 gives you 5 and 5 plus 7 gives you what answer? 12. So does 12 come in the table of 3? Yes. So this number will also come in the table. 3, okay, into 4 times is 12. 2 carries 3 into 9 times is 27. Then what you have 49. Now you know 49 is directly divisible by 7 only because 7 into 7 gives you 49. So this is a prime factorization. All right. Now what you have? 1 minute, children. What was the whole question? Okay, the question was, is 2352 a perfect square? And then afterwards the question stated, if not, find the smallest multiple of 2352, which is a perfect square. So what you will do, see, when you look at the prime factors of 235, so I get 2352 is equals to 2 into 2 into 2 into 2 into 3 into 7 into 7. So I can make pairs over here. One pair, second pair, and third pair. 3 is left alone. It does not form a pair. So what will I do? If I add one more 3 to it, if I add one more 3, now I can make pair with 3 as well. And now this becomes a perfect square. Right? So when I multiply it, 2, 3, 5, 2, multiply it with 3. So what do I get? 7056. That means 7056 is the smallest multiple of 2352, which is a perfect square. Do you understand this? Whenever you have such type of questions.
Can I ask you something?
Yes.
Where did the 1 come from? Or 2, like 2 upon 1?
Let us speak a little loudly.
Where did the 1 come on the 2? 2 upon 1.
Where 2 upon 1?
Here.
This one. I was just multiplying. Forget it. I was just multiplying. Okay. 2352 into 3. I was just carrying the number. 3 into 5 is 15. So 5 I wrote over here, 1 I carry. Yes. So I hope this question was clear to you. Now, see what, there's one more very important thing. Now here you can also do this question in one more way. If the question was, the question can also be asked to you, with what smallest number must you divide 2352 to make it a perfect square? Now, see, if you add one more 3, then also you will get a perfect square. But what if I remove this 3 as well? Now this number also becomes a perfect square, isn't it?
Yes,
Even
ma'am.
on removing the either I can make the single digit as a square number. Okay, I can multiply one more of the similar kind, or I can remove the existing digit as well. I can go both the ways. So even if I will divide this number by 3, then also I'll get my answer. Okay, children. So we'll come to those type of questions as well. Next question. Next is a similar one. With what smallest number 9408 must be divided so that the resulting this is how you this is what the question. So what you will do here, you will again do the prime factorization of 9408 and then check for the numbers, make pairs out of it, and whatever single number you have, you will divide it by that number. Okay, try to solve it, children.
Sure, ma'am.
Okay, so let's discuss the solution. What about Rida? Have you done?
Yes, ma'am.
Okay. So Mustafa, you can tell me the solution of this one. How do you do prime factorization? I need to zero it. How do you do the prime factorization, Mustafa?
Yes, ma'am. Uh, so it becomes 2 fours are 8, carry 1, then it becomes 2 sevens are 14, and then 0 will go there, and then 2 fours are 8.
Okay.
Uh, I 2 twos are 4,
Okay.
then 2 threes are 6, 1 carry, 2 fives are 10, 2 twos are 4.
Okay. Then again by 2. So 2 into
2
1,
ones are 2.
1 time, 7 times, and 6 times. Again by 2, 5 times, 8 times, 8 times. 2 into 2 times, 9 times, and 4 times. 1 time, 4 times, 7 times. Now 147. Now this can't be divided by 2. So this with which number have you divided?
Ma'am, 3.
3. Very nice. So 3 into 4 times is 12, and then 2 carry 3
3
into 9.
times 27.
Then
7 is 49.
7 into 7 times you get 14, and 7 into 1 time, right? So now what are we getting? We get 9408 is equals to 1, 2, 3, 4, 5 times 2, and
Ma'am, 6
10.
times 2.
It's 6 times 2. Then 3, and then 7 into 7. So how can you make pairs over here? First you have a pair of 2. Then you have a pair of 2 again. Then again, and 7. Now which number is being left, which is not a pair? 3 is not a pair.
3.
So with either I can multiply with 3 to make it a perfect square, or I can divide it by 3 to eliminate that 3 that's existing. Okay, so both the ways my answer becomes a perfect square. But the method that you're going to use depends on your question. If the question says find the multiple of 9408, then you always multiply with the number that is being left alone. If the question says with what smallest number must you divide the given number, okay, then you're going to divide. So do you understand the concept? Which method are we going to use when?
Yes, ma'am.
Very good. So here the question is, what are they asking you? With what number must you divide? So what are you going to divide with? You're going to divide it by 3. So 9408, you divide it by 3. You get 3136. So 3136 is the nearest number, which is the perfect square. All right. Then we have the next question. It says, okay, one more important question. Find the, Rita, do you understand the previous question?
Yes, ma'am.
So we are moving to the next one. The next question says, find the smallest square number divisible by each of 6, 9, and 15. So you have a set of given numbers 6, 9, and 15. And now you have to tell me the smallest square number. See, what are square numbers? 25 is also a square number. 16 is a square number. 36 is a square number. 49 is a square number. Right? All these are square numbers. So tell me the smallest square number which is divisible by each of the following numbers. Okay, so do you understand what is the question?
Yes, ma'am.
So how did that you understand it? Rita, please do not focus on writing in the class. Okay, this hinders your attention. First, focus on the class. Whatever I'm teaching you, try to grab concepts. All of this is there in your textbook. After the class, please revise it from your textbook itself. Okay, so now 6, 9, and 15. First of all, you're going to find out the LCM of 6, 9, and 15. So how do you find the LCM? You'll do the prime factorization together. 6, 9, 15. Children, you know how to find the LCM or not?
Yes, ma'am.
Yeah. So we do the prime factorization together. First, you divide by 2. 3 times. This remains the same only. Then you divide by 3. Then again by 3. Then by 5. So what do you get? 2 into 3 into 3 into 5. So it will be 3 into 3 is 9, and 9 into 10 gives you 90 as your answer. Now you get 90, which is the LCM. So LCM means, see, understand the concept. Why am I finding the LCM, not HCF or not any other thing? Why I'm not multiplying them? The concept is LCM means the lowest common multiple. That means LCM is the number which is divisible by all these three numbers, right? LCM 90 is divisible by 6, by 9, and by 15 also. Right, children? So I find the LCM of all these numbers. But I get to know that 90 is not a perfect square. It is the LCM. It is divisible by all three, but it is not the perfect square. So now, can I anyhow make 90 a perfect square? Tell me, are there any methods of making 90 a perfect square? We studied two methods earlier, either by dividing by a number or by multiplying that by a number. So can I do prime factorization of 90? Children, are you able to understand?
Ma'am, I don't understand why you're doing prime factors in 90.
Why I'm doing prime? Okay, Mustafa. Tell me one thing. Do you understand this much that 90 is the number which is
Yes.
divisible by all three?
Yes, ma'am.
Okay.
Yes, ma'am.
What is your question? Find the smallest square number. Okay, which is divisible. Now, the number that you're finding should be divisible also, and it should be a square number also. Both the conditions should be met. 90 is divisible, but is 90 a square number?
No, ma'am.
No, 90 is not a square number. So can we make 90 a square number?
Yes.
Can we make
Yes,
it a square number? Yes, we can. What are the methods? First, you will find out the prime factorization. Find out the prime factors. You get 2 into 45 times, 3 into 15, 3 into 5, and 5 into 1. So what do I get? 2 into 3 into 3 into 5. Now tell me one thing. If I multiply with one more 2 and with one more 5, does it become a
Yes.
square number now?
Yes, ma'am. 900.
Does become a square number. So now what is your answer? You multiply 90 into 2 into 5. So answer will be 900. 90 into 2 into 5 gives you 900. Okay.
Yes, ma'am.
So 900 is the number. See, now 900 is divisible by all three numbers also. It is a perfect square. Okay, so this is how you're going to do this type of question. Now, this was an important question. So you should be practicing such type of questions. Okay. Next, what you have is, okay, now you have the exercise questions only. So children, I'll be giving you a few exercise questions as your homework. Please attempt those, and the remaining exercise we'll be practicing in the next class. Okay. Two more classes probably will take, and then we'll be done with this chapter. So please positively keep revising previous parts. Okay, keep revising the square part, and also like whatever I'm teaching you in the square roots. But because this chapter is more about remembrance of all the methods, because there are a lot of methods, a lot of ways of doing the question. Okay, so positively keep revising everything. And any doubts if you have in this lesson, you can ask me. Any doubts from today's class?
No, ma'am.
Okay, everything was clear?
Yes, ma'am.
Rida, was
Yes,
everything
ma'am.
clear to you? Rida, make sure that you're watching the previous recordings. Okay,
Okay, ma'am.
and please join the class on time. Joining 10 minutes late, every day you're going to lag behind. Okay, I've told you this multiple times, and I'm telling you again and again in every class. Please join the class on time and positively view all the recordings of the previous classes so that you're not lagging behind from other students. Okay, Rida? And
Okay.
practice the exercise questions, whatever homework I'm giving you. I've seen that you're not even attempting your test. You're not even like submitting your homeworks. So submit your homeworks, attempt your test on time, and join the